So predict if the molecule below are going to have a dipole moment that is non-zero or not. Pause the video and attempt it, and then start when you're ready. So the following molecule here, it's a hydrocarbon, pretty much like benzene and naphthalene is. This is an aromatic system. As you can see, this has 10 pi electrons, and therefore you would expect this to be aromatic. But looking at the structure, you might think that this is a non-polar molecule because it's all hydrogens and carbons like any hydrocarbon aromatic compound is. But this compound is not going to have a zero dipole moment. It is going to have a non-zero dipole moment, because you can write resonance forms where you will have electron density on one ring and a positive charge on the other ring. So one way to understand that is to write a resonance form such as this. And if you look at this resonance form, you can see that this ring is by itself an aromatic system because it has 6 pi electrons here, and the other 7-membered ring, the heptatriene ring, is also going to be aromatic just on its own, because you can see this also is a completely conjugated 6 pi electron system with a positive charge, whereas this one is a 6 pi electron system with a negative charge. You might have seen this in individual cases, that the cyclopentadienyl anion is an aromatic system because it has 6 pi electrons that are conjugated, and the heptatriene cation is also what is called as a tropylium ion, is also a 6 pi electron system that is conjugated. So azulene is actually a combination of these two individual cases fused together, and because the pi electron system on the 5-membered ring is by itself an aromatic system with a negative charge, and this one is an aromatic system with a positive charge, this molecule is going to have a very strong net dipole moment. In this case, if you want to make both these rings aromatic, what happens is you will be able to write a resonance form that looks like this, and you can pull an electron and you will get a negative charge here and you will get a positive charge here. So while the tropylium cation side of the molecule is aromatic because it has 6 pi electron systems, the anion here is anti-aromatic. Therefore, the anti-aromaticity of this structure will prevent this molecule from having a dipole moment. Therefore, you will expect this molecule to have a zero dipole moment. This is very similar to the azulene situation. If you pull electrons towards that ring, then this becomes a 6 pi electron system on both sides. So because of that stability, you would expect this molecule to be stable as cyclopentadienyl anion and the tropylium cation structure, and therefore this will have a net dipole because this is a stable molecule with this resonance form as the major contributing form. So this is non-zero, this is zero, this is non-zero, and this trifulvalene is again one such system. So if you take electrons from that carbon, you have a cyclic system which is going to have 2 pi electrons in the ring and a negative charge on the other side. So breaking that bond will have a negative charge that is localized, but here this positive charge can be delocalized, and if you apply the 4n plus 2 rule, 4n plus 2 electrons where n equals 0, then this becomes a 2 pi electron system that is fully conjugated. So the cyclopropylium cation is actually a aromatic system. So therefore here also you will expect this to be a non-zero dipole moment because of the aromaticity leading to separation of the charges. And very similar to this molecule, this structure is also going to be a zero dipole moment structure. So non-zero or greater than zero dipole moment, 0, greater than 0, greater than 0, and 0 dipole moment.